Okay, so now we're at the point where we can put all of this together. We have representing a system of equation as an augmented matrix. We can use row operations to manipulate the elements of a matrix, row by row, and now we want to use what is called Gauss-Jordan elimination in order to end up with a matrix that can tell us the solution to the system of equations. The way Gauss-Jordan elimination works is the first thing you want to do is get a 1 in the 1, 1 position. So remember, 1, 1, this is telling us the first row and the first column. So if we were to draw a matrix, we want this entry in the 1, 1 position to be a 1. Once we have a 1 here, we're going to do what's called pivoting. Now, pivoting means that you're going to make the rest of the entries in that column a 0. So using row operations, we're going to try to manipulate this matrix so we'll end up with zeros along the rest of the column. Once we've done that, then we move on to the second column. We want to get a 1 in the 2, 2 position, and then we'll use this to pivot the second column. So we'll try to get zeros everywhere else in column 2. And you keep going this way until you've eliminated most of the coefficients and you just have 1s all the way across on the diagonal. The reason that this is helpful is, say you have a system and you simplified it down, so we have a diagonal matrix with 1s on the diagonal, zeros everywhere else, and let's say that you have a 3, a -2, and a 4. Well, what this tells us then is that if we read across the first row, and let's say that this is x, y, and z, the first row tells us an equation, x plus 0y plus 0z equals 3. So in simpler terms, it's giving us the solution, x equals 3. The second row tells us y equals -2, and the third row gives us that z is equal to 4. So by using Gauss-Jordan elimination, we can end up with a matrix that looks like the one we have here, and we can easily read the solutions. Instead of having to do elimination by hand, we can do it a little bit faster here. So let's see how we use this in practice. So let's solve the system of equations represented by the given augmented matrix. So the first thing we need to do is get a 1 in the 1, 1 position. Now there are a couple ways you can solve this, but I try to take the path of least resistance. So I already have a 1 in the first column, it's just in the wrong row. I need it to be in row 1. So I'm going to use my row operation of interchanging 2 rows in order to move row 2 up into row 1. So I'm going to switch row 1 and row 2. And you do need to indicate which row operations you're using at each step. So I'm switching row 1 and row 2. So now I have the new matrix, 1, -2, 7, 3, 4, 1. This is equivalent to the one we started with, it's just a different order. So now I've met the first step for my Gaussian elimination. I have a 1 in the 1, 1 position. Now I'm going to use that 1 to pivot, making the rest of that column 0. So that means that my 1 is okay, but I need to make this 3 into a 0. Well, in order to make that 3 a 0, I would need to add to it a -3. Or you can think of that as subtracting 3. And so that's exactly what I'm going to do. But I can only do that by using row 1. So the first thing I'm going to do is I have to ask myself, what can I multiply by row 1 so that when I add it to row 2, it's going to make that 3 a 0. So essentially, what do I need to multiply by 1 so that if I add it to 3, it will be 0? And that would, of course, be -3. In general, you're always going to take the opposite of the term you're trying to turn to 0. So if this was is a 3, then I'll do -3 times row 1. If this term was a -4, then I would do +4 times row 1 plus row 2. And this changes row 2. Okay, so let's see. Now this is where it's up to you how much work you show. I need to see the indication of the row operations, but you don't have to show me all the arithmetic on the side. Since we haven't changed row 1, right, our target row is row 2, row 1 is going to stay the same. So we'll have 1, -2, and 7. Row 2, however, is going to change. So I'm just going to show the scratch work here so we can get more practice. If I take -3 times row 1, that gives me a -3, a +6, and a -21. I'm going to add that to row 2, which is +3, +4, and +1. This gives us a 0, a 10, and a -20. So my row 2 is now 0, 10, and -20. Okay. So we have successfully pivoted on the first column. So let's see where we are. We pivoted and we made the other terms in that column 0. So now we need to get a 1 in the 2-2 position. So let's see. The 2-2 position is currently a 10. So if I need that 10 to be a 1, then that means I need to divide row 2 by 10. So I'm going to do 1 over 10 times row 2, and this will change row 2. So let's see, row 1 will stay the same. So we'll have +1, -2, +7. Row 2 will be divided by 10. So we'll have 0, +1, and -2. Alright, so we have a 1 in the 2-2 position. Now we need to make all other terms in the second column, all other terms need to be 0. So that means we need this -2 to be 0. So we'll follow the same type of pattern that we did before. We want to take 2 times row 2. This time we're using row 2 because row 2 has the pivot element. That's the one with the 1. So 2 times row 2 plus row 1, and we're going to change row 1. So let's see, we'll do our scratch work on the side. 2 times row 2, that would be 0, 2, and -4. And we're going to add that to row 1, which is 1, -2, and 7. So we'll have a 1, a 0, and a +3. Okay, so let's see. Our matrix, row 1 is 1, 0, and then 3, and row 2 is unchanged from before, so we have 0, 1, and -2. There we go. So now we have done every column in the augmented matrix, in the coefficient matrix. Remember, the coefficient matrix is only the first chunk. So we have taken care of all of the columns in the coefficient matrix, and so now we can read our solution. So let's go ahead and call the first variable x sub 1 and the second variable x sub 2. So reading across the first row, we have that x sub 1 plus 0x2 equals 3. And the second row tells us 0x1 plus x2 equals -2. Well, really all that's saying is that we have x1 equals 3 and x2 equals -2. Or we can write this as a coordinate pair, and that would be 3, -2. Either one is acceptable. Okay. Alright, so the idea here, of course, is you want to create what is called a diagonal matrix, where you have 1s on the diagonal and 0s everywhere else. Once you have that diagonal matrix, you can immediately read your solutions just by going across the rows. Okay? The first term will always be the first variable, the second one would be the second variable, and so on and so forth. All right, that's all for now.